Okay, 6.4, we got some more notes going on here. So part 3 starts on about algebraic vectors. And so it tells us here that a vector drawn with its initial point at the origin is called a position vector. And so if you look over there at what they have on the left, vector v, you can see it's starting out of the origin and it's going to the terminal point, which is v1, v2. That's vector v. It's called a position vector. Specifying the terminal point of the vector will completely determine the vector. For the position vector v with the initial point at the origin O and the terminal point at v1, v2, we denote the vector by, notice it says v is equal to, we have a segment OP, which is equal to, notice this, they use kind of like little, they call them, some of them call them brackets, but they're like pointy parentheses, okay? They're different than actual parentheses. So it's going to have vectors, it's going to have those brackets with v1, v2 inside. We call v1 and v2 the components of the vector v. v1 is your first component and v2 is your second component. Note though, now this is different than notation for an ordered pair. Notation for an ordered pair has a parenthesis around it. When you're talking about the position vector, it's going to have those little square, those sharp parentheses, what they call brackets. Okay, and we can use that to find the magnitude of vector v. So it's going to be those brackets, it's v1, comma v2. So to find the magnitude, which is those two bars with the vector inside, it's equal to the square root of v sub 1 squared plus v sub 2 squared. Comes from the Pythagorean theorem. Alright, then equivalent vectors. Says if equivalent vectors v and w are located so that their initial points are at the origin, then their terminal points must coincide as well. If they're equivalent vectors, remember they're going to have the same length and the same direction. So if they're equivalent, they should lie on top of each other. So if we have vector v has a position vector at v1, v2, and vector w is position vector at w1, w2, vector v will equal vector w if and only if, that's what the IFF stands for, if and only if v1 is equal to w1 and v2 is equal to w2. So, representing a vector as a position vector, the vector PQ with an initial point at x1, y1 and a terminal point at x2, y2 is equal to the position vector w, which is equal to, get your little sharp parentheses there again, and it's x2 minus x1, comma y2 minus y1. So you're finding the difference between the x's and the difference between the y's to find what the position vector will be. Alright, so let's look at example 1. Example 1 says let v be the vector with an initial point p at 4, negative 2 and a terminal point q at negative 1, 3. We're going to write v as a position vector. So notice you've got, you know a few things. You know the initial point. So we have an initial point, which remember is going to be your x1, y1. And so I'm going to go ahead and label that. You know your terminal point, which is going to be your x2, y2. So I'm going to label that. And remember, when you're after the position vector, that's equal to little pointy parentheses there, x2 minus x1, comma y2 minus y1. And so let's find that then. So we know our x1 and our y1, we know our x2 and our y2. So let's plug that in here. So we're going to have what, x2 minus x1, y2 minus y1. And so we work that out. We get negative 5. 3 minus a negative 2, that's positive 5. And so there is the position vector for vector v.